Let's crack management exams. Join Unacademy, India's largest learning platform. Get the best possible resources to crack CAT, the GMAT, and all your management exams. My name is Anand Venkatesan, and I'm an educator with Unacademy. Here's a brief look at my profile. I've completed my engineering from VIT Vellore and then went on to do my postgrad from IIM Bangalore. That's when I decided to do what most management graduates do, get myself into a comfortable job. I worked for about 4 years in the FMCG sector with one of India's leading companies. And for the past decade or so, I've also trained students for a variety of these entrance exams. I'm a quant instructor, quant and verbal instructor, in fact. And over the years, I've seen hundreds and thousands of candidates get into their coveted B schools under my tutelage, under my guidance. Alright, enough about myself. Here's a quick sort of word on the Unacademy platform. It's, personal opinion, one of the best platforms to learn and prepare for entrance exams, because you get everything that you need to prepare, right? Classes, right? Live classes that happen daily. In fact, multiple options every day that you can attend live. You can take tests and quizzes, so you can practice what you learn in class, apply them on problems, see if you're doing well or not. I think most important of all, you get structure to your preparation. You know when to prepare, what to prepare, how to prepare, and you also have the luxury of educators who can track your progress, maybe even give you tips and tricks, and clear up all your doubts. And the most important thing of all, you get unlimited access to all the resources on the platform, because once you subscribe, there's no upper limit on how many batches you can join, how many videos you can watch, how many times you could rewatch a video, in fact. So all of that is unlimited. Right, so one of the most important things for a learner is the quality of educators, and let me reassure you that the educator profile on Unacademy is of the highest pedigree. These are people who are subject matter experts who've been taking CAT, GMAT, SAT, all these multiple exams year on year, and have been scoring 99 percentile and more, right? So these are people who know what strategies work in the exam, and by clocking these insane amount of minutes on the platform, they also know how to deliver it in a classroom, even if it is online, right? So that's the big advantage that you get. Talking about live classes, there are two kinds of live classes that you can attend on the Unacademy app. One is called Special and the other one is called Plus. The main difference, let me talk about Special first. Think of special classes as trial classes, because these are entirely free of cost. All you need to do is register on the Unacademy app and you can start learning through special classes. Once you've attended special classes, you can experience the kind of engagement that happens on the platform, how the educator profile is, and so on and so forth. But eventually, if you are chasing many learning, many batches, many options to learn, Plus is the way to go, because Plus, first of all, to access Plus, you need to subscribe. But if you subscribe, you get to enroll in batches, not one batch, not two, multiple batches that you could join, and each of these batches will have live classes, as you can see. Every single batch will have live classes that happen at different points in time over the week. So basically what you get is multiple options, right? You can generate multiple options for yourself by joining the Plus platform, right? And these are the kind of batches I'm talking about. I think the sheer variety of batches available will make sure that it caters to all your needs, right? If you want help with basics, hey, we've got a batch that works on basics in a slow and sustained manner. If you want a crash course, maybe you want to finish off the syllabus in a month or so, again, we will have batches for that. Maybe you need help with a specific area, a micro batch in a sense, areas like arithmetic, geometry, or reading comprehension, parajumbles, and so on. Or maybe you want to tailor your preparation for a particular exam like the TIS or XAT or a SNAP, and all of those will be available as batches when you join the Unacademy platform. One of the batches shown up here is a batch that I'm part of. That's the Extreme Batch 2021. In fact, just today I kick-started a new module within this batch for number systems. So we go live every Saturday and Sunday at 10 in the morning, and that's when a session happens. So do make sure that you check that course out. It's called the Extreme Batch 2021, and specifically my course there is called the Number System Comprehensive, sorry, the detailed course on number systems for CAT 2021, right? But that's not all, right? There are many more batches that are going live. Some of the ones that you'd want to check out, the beginners batch for CAT 2021. This is a batch that starts tomorrow, the 21st of December. Another batch for the CMAT goes live again tomorrow. That's 21st of December, and then there's a third batch which is starting up on the 23rd of December, and do make sure that you download the app and check out these batches, exciting batches. There are every batch. The advantage with Unacademy is that for every batch you also have an intro video, right? So the description and intro video will tell you what to expect in the course, and the educator themselves, right? So make sure that you check out, that you visit the Unacademy app and check out these courses, all of them. You can see right at the bottom I've mentioned a referral code. In case you decide to join any of these batches, just use my referral code AV01. That gives you a 10% discount straight off, right? And you need that when you're subscribing to one of these plans, right? You can see plans go from as short as a month long, but can go as long as even 2 years. Well, personal opinion, the longer the duration, maybe a year or so, the better it is for you in your learning journey, because not only do you get to prepare for the exam, but also for GDs, interviews, and also get to interact with some of these stalwart educators. Right? Let me again remind you that my referral code AV01 will give you a 10% discount on any of these subscription plans. Right? All right. So enough of an intro. Let's dive into today's session. Today we look at arithmetic for the GMAT. This is part of a 3-lecture series on arithmetic for the GMAT. Well, arithmetic in any exam is important. Algebra in any exam is going to be pretty important, and more so on the GMAT, because a lot of questions on data sufficiency, which is kind of the harder question type, could potentially come from either number systems or algebra, right? So we need to be good with this, right? So today we'll look at a few things. Let's start off with a quick discussion around polynomials. No discussion on algebra is complete without a quick sort of look at polynomials and expressions. So what exactly is a polynomial? The word polynomial contains the answer. Poly means many terms. So a polynomial is an expression that has many terms. The degree of a polynomial tells you, what is the number of roots or zeros for a polynomial. Let's quickly define those. The degree, first of all, is the highest power of any variable in that expression. If you have multiple variables, you add up the powers in every term, and between terms you consider the highest degree, highest power that you get. Right? So overall, for any algebraic expression or equation, you can define a degree. But the degree will also put an upper limit on how many roots or zeros there are. Now, what is a root? Well, a root is that value of the unknown variable which satisfies the equation, right? Which a root basically makes that value which makes left hand side and right hand side equal is called a root. A zero, on the other hand, is something which is valid for a polynomial but not for an equation, because a polynomial doesn't have two sides. So what does a zero do? It's that value which makes that expression zero, right? And the degree of a polynomial tells you the upper limit on the number of zeros or roots that can exist. So a degree 3 polynomial could be expected to have at most 3 roots. It doesn't mean that 3 roots exist, by the way. It could mean that of the 3 roots, maybe 2 are imaginary. In fact, that sort of reminds me of one more fact, that remember to tell yourself, whenever the roots or the zeros for a polynomial are irrational or imaginary, they do occur in conjugate pairs, right? So there's no chance of an irrational roots occurring in isolation. It will always have a conjugate pair as existing, right? Just keep that in mind. Now, one of the useful properties when we deal with polynomials is something called the remainder theorem. What this says is that if a polynomial f of x, right? Now remember that I'm calling f of x a polynomial because what is a polynomial but what is a polynomial if it's not an expression or a function in x, right? It will have multiple terms, all of which will have the variable x. So that's what we can call as a polynomial in x. If a polynomial f of x is divided by x minus a, right? Remember, you are dividing it by a linear expression x minus a, then this remainder theorem says that if you want to calculate the remainder, all you need to do is substitute a in the expression for fx, right? So as an example, if let's say that I have x cubed plus 5 which is being divided by x plus 1, then I'll say sure, I can do the division, but if I wanted the remainder straight away, then remainder would be equal to f of, right? So first of all, put x plus 1 as x minus a, that gives me the value of a as minus 1. So the remainder should be f of a, which means f of minus 1. So substituting minus 1 in the function right on top, you will get minus 1 cube plus 5 gives me the remainder as 4, right? So you can test it out. If you do perform the division, you will expect to get the remainder as 4, right? So that's how you apply the remainder theorem. But in itself, the remainder theorem isn't very useful because rarely ever will you get a question that or a problem that asks you to calculate the remainder of a division. So why is it useful? Well, a corollary of the remainder theorem, which is called the factor theorem, is in fact what I want you guys to keep in mind, right? What is the factor theorem? It says that for x minus a to be a factor of a polynomial f of x, the remainder should be 0, right? Sure, that makes sense, right? For something to be a factor, it must completely divide, which means there must be no remainder. But where do I get this expression for remainder from? The remainder theorem. So the remainder theorem says if you are dividing an f of x, a polynomial f of x by x minus a, the remainder is f of a. And if this remainder is 0, then x minus a would be a factor, right? So for x minus a to be a factor, f of a must be 0, right? So what does that mean? Why is this useful to us, right? Well, the factor theorem is very, very useful in factorizing or solving degree 3 expressions, right? Over the course of this session and the next, we will recap how to factorize and solve linear as well as quadratic equations. But and there are rigorous approaches, algorithmic approaches to solving those. But not so for cubic or higher order equations, higher order polynomials, because the moment the degree is 3 or more, you can't really use the factor theorem. So you will have to rely rather on the factor theorem. So consider an example. Let's say I want to factorize x cubed plus 4x square plus 4x plus 1, right? Let's say this is what I want to factorize, right? I want a factor, right? So factor theorem will tell me if I want a factor, I want some value which makes the function equal 0, right? So now I start doing a little bit of fit and trial. What I do is I put x as minus 1. Let's see what happens. Minus 1 cube is minus 1. 4 into minus 1 square is plus 4. 4 into minus 1 will be minus 4. And this is plus 1, right? Indeed, you can see this becomes 0. If f of minus 1 is 0, this immediately tells you that x minus a or x minus minus 1 is a factor, right? Which means I now know that x plus 1 is a factor, and that will help me, factorize this expression, right? So that's how you apply the factor theorem. So quick sort of note that you should make is that the factor theorem is very useful for degree 3 or degree 4 polynomials if you ever come across that in the exam. Okay. Consider this example. What's the remainder when x power 4 plus 5x cube plus minus 3x square plus 4x plus 3 is divided by x plus 2? Well, in a nutshell, all you need to do is put x equal to this, equate this to x minus a, which tells you a would be equal to minus 2. So remainder should be f of minus 2. What does that give me? Minus 2 to the power 4 is 16. 5 into minus 2 cube, minus 8 into 5 is minus 40. Minus 3 into 4 is 12. 4 into minus 2 is minus 8 plus 3. right? What do I get? 16 plus 12, 28. 28 plus 3 is 31. So I get 31 minus 48, that's going to be minus 17. So the remainder, if you do perform this division, will be minus 17. Right? Okay, here's another example. Right? And I want you to try this one out yourself. First, I'll give you a minute. If the given expression gives a remainder of 4 when divided by x minus 1, and x plus 1 in fact gives you the remainder as 3, then what would be the value of b? Let me hear it. Just let me know in the chat what you get. Sorry about that. Talk to me in the chat, guys. Are you getting an answer for this? I keep checking the chat to see if you guys have solved it. Still comes up blank. What's up, guys? If you're watching a recording of this, at some point when I start speaking, if you still haven't solved, pause it by all means and try this question out. It's not a very hard question. You should be able to solve it if you know about remainder theorem, that is. Right. Right, I think it's time we tried this one out, right? So first you know the remainder, right? So this is going to be the remainder equals f of, so this is x minus a is 1, f of 1. What is f of 1? 1 plus 8, 9 plus a minus b plus c would be equal to 4, which basically means a minus b plus c will be equal to minus 5, right? Similarly, the second remainder is 3, which would be when x plus 1, it's divided by x plus 1. So the remainder of f of minus 1 should be equal to 3, right? Which basically means minus 1 plus 8, 8 minus 1 is 7. 7 minus a minus b minus c would be equal to 3, right? So a plus b plus c is in fact equal to 7 minus 3, 4. So using these two equations, can you get the value of b? Well, all you need to do is subtract, right? Subtracting, a and c will get cancelled out. You'll end up getting 2b equals 4 plus 5, 9, which means b would be 4.5. Not sure why you got 5.5, Shaurya. Tell me, there's a mistake you made. Although it's not really worth a mistake because it's a fairly straightforward question. Let me move on, right? Here's another question. What's the value of k plus abc? Cubic equation. You can see the moment you see a cubic expression. Okay, wait. Oh yeah, correct. My bad. Absolutely. This should be 9, right? 9 minus 3 should be 6. If this is 6, then this would be 11. And so the answer is indeed 5.5. Thanks for pointing that out, Shaurya. Right. Here's the next one. Given expression, cubic expression should nudge you to use the remainder theorem, the factor theorem. What's the value of k plus abc? What do you think? Making any headway on this one? And you can see that the problem expects me to factorize it, and to factorize it I'm going to use factor theorem, and to use factor theorem I'm going to need to do a little bit of hit and trial, right? Get a value which makes this expression somehow equals to 0, right? So the first part The first step to this question is to find out a value which makes it 0, right? And you know, you look at this expression and you're already thinking maybe negative value. Yeah. So let's try -1, right? What happens if I put -1? -6 plus 19 minus 2 minus 3, right? 6 plus 5 is 11. 19 minus 11 will be 8. No way this is 0. What about -2? 6 into -8 is -48. 19 into 4 is 76. 2 into -2 is -4 minus 3, right? So again, not 0. What is f of -3? Okay, 6 into -27, that's -162. 19 into 9 is 171. Plus 2 into -3, that's -6 minus 3, right? So you'll end up getting, check this out, this becomes 0. 162 plus 9 is 171 with a negative sign, which means it will cancel out, right? And since f of -3 is 0, you stop at that stage. Second step, this means that x minus a, that's x plus 3, must be a factor, right? Okay, now we know x plus 3 is a factor. How do I use that? Well, you start with the original expression, 6x cube plus 19x square plus 2x minus 3, and say this should be a product of the factor that I have already figured out, x plus 3, into something else, right? And so what we can do is we can start, you know, building those terms, right? X into something should become x cube, 6x cube rather. So you multiply the 6x square, that gives you 6x cube plus 6x square into 3 is 18x square, right? But you want it to be 19x square, right? So if you want 19x square, you want one more x square. So multiply x with x once again, right? So that will make it plus x square plus 3x. Together these two terms will make 19x square. So 2 terms out of 4 are done. Now I'm left with 3x, but I want to make it 2x, right? Clearly I want to subtract an x from it. So to make minus x, you multiply x with -1, that makes minus x minus 3, and it also gives you the 3 that you want, the constant term that you want. So there you go. And now the second bracket is a quadratic expression. I hope you guys remember how to factorize the quadratic. This becomes x plus 3 times, you know, what is this, 2x plus 1 into 3x minus 1, right? There you go. The 3 factors, right? And the moment I get the 3 factors, I can now equate it to this expression, right? But notice that in the given expression, the coefficient of x is 1 in every factor. So I'll have to manipulate this slightly, right? Take a 2 common here, take a 3 common here. 2 into 3 becomes 6 on the outside. This becomes x plus 3 into x plus half into x minus 1 by 3, right? So you're thinking one of these is a, one of these is b, one of these is c, and this is k, right? So the question asks me for the value of k plus abc. That's 6 plus a into b into c. Right? 3 and 3 will cancel out. 6 minus half is 5.5. Right? So it turns out even this question, the answer to this question is also 5.5. Does that make sense now? I certainly hope it does. Another question, given expression has positive real roots, find the value of a minus b. Alright, I know that I got you guys in a difficult position on this one. Not getting any response from you guys. Yeah. Yeah. Okay. Yeah. Actually, this question needs a little more foreknowledge, right? Because let me give you a hint, and we'll revisit this question when we deal with quadratic equations. This question will be solved by using the expression for sum of roots. Okay, that's the big hint, right? I hope that you realize this is a degree 4 expression, so you'll think it has 4 roots: alpha, beta, gamma and delta, all of which will be positive. But then you can make expressions for the sums in many ways. There's sum 1 at a time, 2 at a time, 3 at a time, 4 at a time. That's something that you need to look at, right? I can solve it for you. I'll show you what needs to be done. Basically, what you'll say is that the sum of all the roots in this case would be minus b by a. So that's going to be 8. And the product of all these roots, right, the same 4 roots, would be equal to 16, right? And it turns out that there is only one, and all of them need to be positive, right? So if all of them are positive, this will happen only if all of them are equal to 2, right? 2 plus 2 plus 2 plus 2 is 8, and 2 into 2 into 2 into 2 is 8, which means all 4 roots are equal to 2. And if that's the case, then the equation is actually x minus 2 raised to the power 4. So all you need to do is then expand this and get the value of a and the value of b separately, right? And that's the way that you solve this question. It's a tricky problem, right? And it relies on the fact that all roots are positive, but it also relies on you spotting the sum and product of roots, right? I think an important reminder that whenever you come across higher order polynomials, there are only these two approaches that you can use. You can either use the factor remainder theorem, or you could use expressions for sum of roots and product of roots, right? Alright, the second most important thing is to know your identities well. Algebra, don't be surprised if you get questions based on identities like a plus b whole square, a minus b whole square, a square minus b square. In fact, two identities which rely on that. If you want to get the expression for a square plus b square, all you need to do is add a minus b whole square and a plus b whole square and half their sum, right? Similarly, if you want the value of 4ab, subtract these and again half their difference, right? That's one way. Other expressions: a plus b plus c whole square, a plus b whole cube, a minus b whole cube, right? Be careful with the signs here. And again, derived expressions for a cube plus b cube and a cube minus b cube, right? So make sure that you that sometime through the day, following a couple of days, that you spend some time with listing out all of the formula on a formula sheet and maintain that, use that, right? Make sure that you don't forget any of these expressions. The one at the bottom is used relatively rarely, but then in wherever it does apply, this is the only thing that works, right? So make sure that you know your algebraic identities. Let's look at some problems based on this. You can see at the onset, numerator a cube plus b cube, right? Expansion a plus b into a square plus b square minus ab. And then you divide it by the given denominator, and lo and behold, the given denominator is the same as the one that occurs in the numerator. So clearly that will cancel out, and so you are left with 55 plus 45. That's option A, equal to 100. Right? So you can see you can see that the expression, this kind of a problem will rely only on you knowing the identity, right? Many such questions. Okay, here's another one, right? Try and answer this. 5 power 6 minus 1 will be divisible by which of these given numbers, a, b, c, or maybe it's divisible by none of these. How do you figure it out? Indeed so, right? You can see that this is, you can write this as 5 square the whole cube minus 1 cube. A cube minus B cube will be, right? So basically this becomes 25 cube minus 1 cube. So that will be A minus B, that's 24, into A square, that's 25 square, that's 625, plus B square, plus AB, that's plus 25, right? So what I end up getting is 24 into, what is this, 651. Yeah. And you can easily verify, is this a multiple of 31 or not? Well, 31 into 2 is 62. I'm left with 3, I get 31. So yes, this, 651 is divisible by 31. Right? So that's the right answer, right? This expression must be divisible by 31, not by 13. Definitely not by 5. Okay, how about this one? Question number 7. Given this expression, 7 power 6n minus 6 power 6n, where n is an integer which is positive, what will this expression be divisible by? Will it be divisible by 31, 127, 559, or none of these? Let me tell you, it's not easy. Right? Give you a minute to sort of soak this in. Exam is a little harder, isn't it? The kind of question that should tell you you're doing well in the exam. How do I approach this? Well, I know I'm going to use a cube minus b cube or a square minus b square, one of those properties, right? Well, it turns out that it's not just a cube minus b cube, it's also in fact there's a general property. The general property is a power n minus b power n, right, is always divisible by a minus b. And in fact, whenever n is even, and this is also divisible by a plus b. Right? Think about it, Ben. As long as you have an expression of the form a power n minus b power n, both terms having the same power, if it's a difference, if it's negative, if it's a power n minus b power n, it will always be divisible by a minus b. But if n is even, it will also be divisible by a plus b. And likewise, not really useful in this problem, but if it's a power n plus b power n, then if n is if n is odd, then this expression is divisible by a plus b, right? So those are a couple of properties that we'll use. So here I'm going to use this first property, right? Try and prove that if it's a difference, then it will be divisible by a minus b, right? Let's go with this. So at the onset, if you do a power n minus b power n, powers are equal, it should be divisible by 7 minus 6, 1, which really doesn't tell me much, right? But what I can do is I can manipulate this, right? I can write this as, for example, I can write this as 7 square 49 to the power 3n minus 6 square, that's 36 to the power 3n, which means this should be divisible by a minus b. What's that difference? 49 minus 36 is in fact 13. So it's divisible by 13. I don't find that in A, B and C, so it's not of much use to me. Right? So instead, I could also write this as, okay, maybe I'll write this as 7 cube 343 to the power 2n minus 6 cube 216 to the power 2n. Yeah, maybe that helps. Let's see. This should be divisible by both a minus b and a plus b, right? So it should be divisible by their difference, which, 343 minus 216, and also by their sum, so 343 plus 216. Let's see where this gets us. Difference 13 minus 6, 7, 3 minus 1, 2, and 2 minus 2, 0, right? So yeah, 127, but also their sum, which is in fact 559. Oh my god. So this one is divisible by both B and C as a matter of fact. So it's a poorly constructed question. I apologize in advance. I think then there was a fifth option which somehow went missing. It should have a fifth option that says it's divisible by both B and C. In fact, it's probably also divisible by 31, is it? No, or maybe not. Right. Okay, that does it for this question. Let's move on. Here's another one. Again, an expression. Tell me n denoted by this expression would be divisible by which of the listed option choices? Right? Would be divisible by A 7 and 13, or by B 3 and 13, 17 and 7, or 3 and 17, right? So number of combinations given over here. What should I do? Should I calculate the value of n and then check whether it's divisible, or is there a better way of doing it? Okay, indeed, you can see this is of the form a cube plus b cube minus a plus b the whole cube, right? And the expansion for a plus b the whole cube is a cube plus b cube plus 3a square b minus plus 3ab square. Yeah? So clearly this will get cancelled out, a cube plus b cube, right? That will get knocked off. So whoops. Right, so where does that leave me? Right, seems to be negative. N would be divisible by which? So if I simplify, I'll get it's definitely divisible by 3, right? So that rules out C and A possibly. But if I take 3AB, right? So this should be 3 into A, which is 55, into B, which is 17, into A plus B, that's going to be 72. Right? This is going to be 3AB into A plus B, right? So it should be divisible by 17 and 5 and 11, and also by 8 and 9 possibly, right? So is it divisible by 17 and 7? No. Is it divisible by 3 and 13? No. Is it divisible by 13 and 7? No. Is it divisible by 3 and 17? Absolutely it is, right? So the correct choice will be option D. It's a number which is divisible by both 17 and 3. How about this one? No, it's not that hard a question actually. It's a question that directly uses the identity. Yeah. Okay, if you didn't already know this, identity is a cube plus b cube plus c cube minus 3abc is a plus b plus c, a square plus b square plus c square minus ab minus bc minus ca. Right? Now, how do I use this? Well, clearly, if a cube plus b cube plus c cube is equal to 3abc, then this expression would be equal to 0. And if this expression is 0 and this one isn't 0, then clearly this must be 0. Right? And if this is 0, then the value of a square plus b square plus c square would be equal to ab plus bc plus ca. That's a very simple option A that we can mark to this question. Yeah. Right? Another question based on the same identity. Well, you can see denominator, right? I mean, in the interest of time, I'm going to quickly tell you. Look at the denominator, and you'll already notice that this is 3 square to the power 1 by 3 minus 3 to the power 1 by 3 plus 1, right? So what do I do? What do I do with this? Well, you should notice that this is 3 power 1 by 3 whole squared plus 3 power 1 by 3 plus 1, right? So you can think of this, you can write it this way and think this is a if this is a square, this is b square, this can be thought of as ab. Which expression contains a square plus b square plus ab? Well, that's a cube plus b cube. So in fact, what is a cube plus b cube? So a cube plus b cube would be a plus b into a square plus b square plus ab. Yeah. So the given expression in the that you want in the denominator would in fact be equal to this upon 3 power 1 by 3 plus 1, right? So what is this? This is 3 plus 1 4. That's exactly the numerator, right? So the numerator can be written as 3 power 1 by 3 plus 1 into the other expression, which will cancel out. So my answer is 3 power 1 by 3 plus 1, option B. Yeah. And I hope that makes sense to you. Give me a thumbs up if you're clear with how I solved this particular question. Right, this is a question I'm going to leave you to try yourself, right? Do revisit this video, find this question, try this question yourself, right? But for now we'll move on, right? Too many questions, too little time. Right? Also look at a few miscellaneous problems. What's the answer to this one? Don't hold out on me. What's the answer? Should be a fairly easy one, right? If this is the value of x and you notice it's a recursive expression all the way till infinity, then this portion can also be written as x. Yeah? Because it also contains square root of 1 plus all the way till infinity, which means I can write x as equal to square root of 1 plus x, squaring it, x square minus x minus 1 equals 0. Quadratic equation, roots will be minus b plus minus root of b square minus 4ac, that's 1 plus 4 upon 2a, 2. Right? So I'm getting, and the thing is that you should also notice that x is the positive square root. Right? Which means it has to be positive, x has to be positive. So one of these values, 1 plus minus root 5 by 2, if you consider the negative sign, 1 minus root 5 will be negative, right? So you can't allow that. So my answer should be 1 plus root 5 by 2, rejecting the minus. So that's option A over here. Yeah. All right, moving on. Similar question. I'll let you try this yourself, right? maybe homework. But about this one, yeah. Let's look at this. Sorry. I can write this as y equals 1 upon 2 plus 1 upon, remember it has to start repeating, 3 plus, and now notice this expression, right? Exactly the same as the original expression. So this becomes y. Right? 1 upon 3 plus y, take an LCM, goes in the numerator, y plus 3 upon 6 plus 2y plus 1 equals y. And cross multiplying, you will get y plus 3 equals 6y plus 2y square plus y. Right? 7 plus, in fact. Right? So my equation becomes 2y square minus 6y plus 3 equals 0. Factorizing it, you get the answer. Right? No, wait. If y gets cancelled out, my equation will be 2y square plus 6y minus 3 equals 0. Right? So D. Yeah, okay, this is question 14. Right? So, no way of factorizing it, but using the discriminant method, minus b plus minus root of b square minus 4ac. So that's plus 4 into 624 upon 2a, that's 4. So what do I get? This is 60, root 60 is 4 into 15. So this becomes minus 6 plus minus 2 root 15 upon 4, or minus 2 plus minus root 5. Sorry, minus 3 plus minus root 5. Clearly, y will be positive, right? So can't be negative, so ignore the minus sign. So root 15 minus 3 upon 2. That's your answer. Root 15 minus 3 upon 2, option D. Not option C. Option D, I thought. Do check it up. Shaurya. I think correct answer would be root 15 minus 3, not root 5 minus 3. Sorry, not root 5 plus 3 by 2. Right, moving on. Right. Last type of question, miscellaneous, right? You will also get cyclic expressions like this: a upon b plus c equals b upon c plus a equals c upon r. If each of these expressions equals r, then r cannot take any value except for which choice. Right? So this is like a trick problem because let me give you a minute to think about it, and we can and then discuss. So the trick here is to, you can write A as BR plus CR. Similarly, B will be equal to CR plus AR, and C would be equal to AR plus BR. Right? What do you think we should do with these? You add them. Right? One way is to add them. What happens? I'll get A plus B plus C should be equal to, what do I get? 2BR plus 2AR plus 2CR. So you'll get 2R into A plus B plus C. Right? Which means this becomes A plus B plus C, right? Don't knock it off, into 2R minus 1 equals 0, right? Which means either R is equal to 1 by 2 or A plus B plus C equals 0, right? So R equal to 1 by 2 tells me that the answer can either be A or C, right? It definitely can't be B or D. They don't contain minus plus 1 by 2, right? But to choose between them, I'll have to use this expression. If A plus B plus C equals 0, right, then R is not half, then what will R be? Now if A plus B plus C is 0, A plus B will in fact be equal to minus C. And if you take this and you substitute it here, right, if A plus B is equal to minus C, then R, which is equal to C upon A plus B, would in fact be minus 1. Right? So if it's not equal to 1 by 2, then R would be equal to minus 1, and so the correct choice is option C. Right? So cyclic expressions, try and manipulate it. Use one of the algebraic identities that you have. Here, fortunately or unfortunately, here we didn't have to really work much harder than this. But here's a question where you might need to do that. Any answers, right guys? 16. You're saying this expression would be equal to 0. Wonder how? Asim agrees. How 0? How 0? Yeah. Now let me share a couple of things with you. Usually, when you see an expression like this, right? Some of the things that you should notice, right? I'm going to call this a cyclic expression, right? I'm calling this a cyclic expression. Why? Because if you swap A with B in the entire expression, you'll see it doesn't make any difference, right? Look at this. A ki jagah expression, everywhere in the expression, if I replace A with B and B with A, will that change the expression? Remember, this will become B square by 2B square plus AC. This will become A square by 2A square plus BC. And this becomes C square by 2C square plus A and B swap. This will remain AB, right? So can you see that it remains exactly the same? The expression doesn't change, right? And usually for cyclic expressions, one thing that you do is you put A is equal to B is equal to C, right? If the expression is cyclic, chances are, if you want to reach a point of equilibrium, then you make all three of them equal, right? It usually would be a starting point, but here it already says that A, B and C are not equal, right? So this approach will fail, right? But there's one other trick up my sleeve. The other trick is that notice that this expression says that if this is true, then this will always be equal to either 0 or 1 or minus 1, right? So that should set your mind thinking. You should think, okay, why would an expression be constant? Because I don't know the values of A, B and C, right? Without knowing the values of A, B and C, this question seems to suggest that the given expression I have will take a constant value, right? Which means it doesn't depend on the values of A, B and C. So why not make it particular? Why not say, well, can I think of some particular value of A, B and C? So maybe I substitute and check, right? Maybe I put A as 0, B as minus 1 and C as 1, right? Can you see that this is a convenient set of values? 0 immediately means, remember, it doesn't say A, B and C can't be 0. They just have to be unequal. So their sum indeed is 0. But if I put this expression put these values in the given expression, what will that become? First term, A square, 0 upon something will be 0. Right? Second term, B square is minus 1 square plus 1 upon 2B square, that's 2 plus A into C. Wherever A comes, that becomes 0. Right? Third term, again 1 upon 2 plus 0. What do I get? What do I get? I get half plus half becomes 1, right? So I know that definitely one value will turn out to be 1. So it has to be option B. The right answer has to be option B. Yeah. Does that make sense to you guys? Yeah. It's a neat little trick, right? I mean, things that you must imagine, that you must foresee. A is the expression cyclic. Maybe I put A, B and C as equal. If it's even if it is cyclic, I can probably even try substituting values. And a third approach, like we talked about, is to use algebraic identities. We don't, in this question we didn't really need to, but you can do so, right? Okay, now that we've spent a great proportion of our time dealing with, expressions and polynomials, let's quickly sort of recap linear equations. I'm sure you know most of this stuff. A degree 1 expression is called a linear equation. We can solve a linear equation when you have as many equations as the number of unknowns or the number of variables. And the way to solve it is to use the substitution and elimination methods, which I hope you know, right? Think about, these two equations shown up on your screen. That's 2x plus 3y equal to 13 and 5x plus 4y equal to 22, right? So if I'm solving it by using substitution method or the elimination method, what does the substitution method say? Express first variable in terms of the second variable, substitute that in the second equation, solve it, right? Elimination, on the other hand, says multiply both equations with constants. So for example, what I could do is, if I want to eliminate x, you multiply this with 5 and this equation with 2, and that will create 10x in both places, which you subtract, which means that x will get eliminated. So you make one equation, one variable with equal coefficients and subtract to eliminate it. That will give you the expression for the other equation, right? Again, quickly running through this because you already would know this. Graphical perspective of linear equations is that when you have an equation in a single variable, that's a point on the number line. If I have an equation with two variables, then that's like a straight line on the xy plane. If you have a linear equation in three variables, x, y, and z, it's not a straight line anymore, it's a plane, right? On in obviously a three-dimensional space, right? And obviously when we are solving, a pair or a system of equations, linear equations, then you're basically trying to find where do these, graphs, where do these curves, or where does this plane coincide or overlap. So basically you're trying to find points of intersections, right? Okay, let's keep that perspective in mind. We will use it. But talking about the types of questions, word problems are the most common, questions involving linear equations. Very, very straightforward. Problem expressed in words. Need to make equations and solve them. A couple of pointers. Whenever you see words like more than, less than, increased by, n years later, you're thinking, something plus something, right? If it's less than, decreases by, it's minus, right? If it's percentage or a fraction or the word times, then I need to multiply, right? 30% of my salary, so 30 upon 100 into my salary, right? Or when it's by or divided by, then you clearly divide, right? And remember, whenever you see verbs like is, was, has, have, are, will be, becomes, that translates into the equal to sign, right? So simple rules that will help you take a problem in, problem statement expressed in words and convert it into an equation, because every word in the question will translate into some algebraic, either an arithmetic operation or a variable or so on and so forth, right? Let's consider an example. In fact, not so much an example. Question that we'll discuss. Sum of three consecutive integers is k, which the following is a possible value of k. What do you think? What do you guys think? Quick answers now. It's not really a word problem, but yeah, it is one based on linear equations. The sum of three consecutive integers. Yeah. So three consecutive integers, I can think, okay, let's say one integer is x, the other one will be x plus 1, the other one will be x plus 2. So their sum is k, right? So k will be equal to x, in fact adding them, 3x plus 3, right? So it should be a multiple of 3, right? Only multiple of 3 here is 201, right? Has to be option C, right? Okay, more of a word problem this. Question number 18th. Solve and tell me what you get. Right, good answer, Deepika. Yeah, ये सब rapid fire की तरह करना चाहिए, right? You guys should be like quick. I mean, target word problems, linear equations, 1 minute per question, right? Anything beyond a minute, you're wasting time. Let's say Ram's age is X, brother's age is Y, right? But the question is, when are these ages X and Y, right? Let's say these are present ages, right? Presently Ram is X years old, brother is Y years old. 4 years ago their ages will be X minus 4 and Y minus 4. But it says Ram was twice as old, right? So it should be 2 times this. Okay, that's equation number 1. In fact, maybe I'll simplify, but we'll think about that later. 3 years hence, X plus 3, Y plus 3. Their combined ages will be 50 plus this equals 50, right? So what do I do? Okay, from here I'll take the value of X and substitute it there, right? Easy to do. 50, this is 6, 50 minus 6 is 44, 44 minus y, substitute that here, 44 minus y minus 4 equals 2y minus 8. 3y equals 40 plus 8, 48, y is 16, so x would be 44 minus 16, that's 28. So find the presence difference of their ages, difference will be 28 minus 16, that's 12 years. If you're taking more than a minute for this, then get faster, practice, guys, practice. And remember, even on the GMAT, any other exam actually, you will get 1 or 2 questions of this nature, of this difficulty level, right? Get better, get faster, right? Learn to do this faster, right? Here's another one. Based on ages. The most common word problem is one based on people and ages, right? See if you can quickly get me an answer to this one. 2x plus y years ago, Roberto was 3x plus y years old. How many years ago was Roberto x years old, right? I mean, you read this, it sort of muddles you, right? See if you can sift through the debris on this. Okay, looks like you guys definitely need help with this. When would be my next class? I think Tuesday 7 p.m. Think so? Yeah. Not sure, man. Keep following my Telegram channel, you'll know. Asim. Yeah. Okay, well, if you're confused in a problem like this, I think simple way is that you take these variables and replace them with numbers and then ask yourself this question, right? So supposing I say 5 years ago Roberto was 30 years old, right? And try and interpret it. If 5 years ago somebody is 30 years old, what's his age today? How would you calculate that? You'll say if 5 years ago he was 30, today he'll be 35, right? How would you get 35? 5 plus 30, right? Which means Roberto's age today would be this plus this, right? So that's 5x plus 2y years old. Okay, that's his age. Okay. What is the question saying? How many years ago was, so supposing, let's go back to values. How many years ago was Roberto 20 years old? Right? How many years ago was he 20? Well, if he's 35 today, then for him to be 20, that would have taken 35 minus 20, that's 15 years ago. Right? How did you get that? You subtracted. So if you want this guy who's presently 5x plus 2y years old, if you wanted him to be x years old, then you'll subtract x from it and say, okay, that would have taken 4x plus 2y years earlier. Right? 4x plus 2y, the answer, right? Good answer, those of you who marked it. Alright, here's another one which is slightly more wordy. Hopefully not very hard for you though. Alright, let me put a clock on this. Let's see how many of you get it done in under 2 minutes. I mean, 1 minute would have been ideal, but yeah, even if you can get it done in 2 minutes. 10 in total? Sure? Are you sure? Okay, Deepika says 30. Intriguing. Let's check it out. Right? So you have these two guys, Ram and Sham. They had a certain number of chocolates. Let's say R and S is what they had. So what does Ram say? He says, Ram says to Sham, if you give me 4 chocolates. Now imagine this. If I turn to a friend and I say, you give me 4 chocolates, and that transaction happens, I'll have 4 more, but the guy who gave me those chocolates will have 4 less. Right? So first transaction, Ram will end up having 4 more, Sham will end up having 4 fewer. And my equation will be, we will end up with an equal number of chocolates. So equation 1 will be R plus 4 equal to S minus 4, which means R will be equal to S minus 8. Right? Let's put a pin on it. We'll use it again. Right? Okay, second scenario. What does Sham say in reply? Sham says, if you give me 7 chocolates. Now if Ram gives 7 chocolates to Sham, Ram will have 7 fewer and Sham will have 7 more. Right? Okay. I will end up, I as in Sham. So Sham has S plus 7, will end up having equal to 4 more, 4 plus, 4 more than double 2 times the number of chocolates with you, as in number of chocolates with Ram. That's R minus 7. Right? Here's my second equation. What happens? Now let me quickly substitute this, right? S plus 7 equals 4 plus 2 times. Now R minus 7 will be S minus 8 minus 7. That's S minus 15. Right? So if I open this up, what do I get? 2S. This is minus 30. Right? So let's bring all of it to the left hand side. 7 minus 4 is 3. S plus 3 equals 2S minus 30, right? Which means I'll get S as 33. Sham alone has 33 chocolates. How many does Ram have? 8 less. S minus 8. 33 minus 8 is 25. Okay, so Ram has 25, Sham has 33. How many chocolates do they have in total? In total, they'll have 33 plus 25. That's your answer, which is 58. Okay. So you guys did take 2 minutes, but then you got the wrong answer. Yeah, let me guess. You guys forgot to add at one end and subtract at the other, right? That's like the most common mistake people make, right? Only add at one place but forget to subtract from the other place, and that completely, gives me wrong answers, right? Well, hopefully this one is clear to you. Let's move on. Okay, interesting. Raman scored 25. Let me give you a minute and see if you get somewhere with this question. 1 minute this time though. Okay. Quickest answer from Shaurya. What do the rest of you think? Alright. Let me try this. Let the variables be A, B for Rohit, C for Sonia, D for Rohan. Yeah. Obviously Sonia is C. Ravi, let's say, is E. Then the maximum marks, let's say M. Right? What percentage of marks did he score? Okay, so we've got all the variables sorted. So what's my equation? What are the equations given here? Raman scored, Raman equal to 25 less minus 25, B minus 2. Okay, then Rohit scored, B equals 45 more than Sonia, B plus C, 45 plus C. Rohan, a variable D, scored 75 marks. D is equal to 75, which is, so 75 is 10 more than Sonia's score, that's C. And Ravi score E is 50 less than the maximum marks, M minus 50 in the test. And so what approximate percentage of marks did Ravi score, right? E upon maximum marks into 100, that's what you want. If he gets 34 more marks than Raman, it's also told, he also says that Ravi scored 34 more than Raman, which is A, right? Okay, can I use this? Okay, first of all, from here I'll get C as 65. If C is 65, put that here, you'll get B as 45 plus 65, that's 110, right? And if B is 110, A would be 110 minus 25, that's 85, right? And if A is 85, then E will be 85 plus 34, that's 119, okay? And if E is 119, then M would be this plus 50, that's going to be 169. So what is the approximate percentage of marks that you want? 119 out of 169 into 100. Yeah. So think of this as 17, 170, let's say. So lock off the 0, 17 into 7 is 119, so approximately 70%. Spot on, Shaurya. It's a very good answer. Right. I mean, I think these are the kind of questions you need to find and solve, right? Even though it's such a voluminous question, the question itself is not very hard. So it's a fairly straightforward question. Yeah. Okay. Well, I think that's all we have time for today, right? I'm going to leave you with this last question. Try this yourself. If you have any problems, do give me a shout. We'll catch up with algebra again next Saturday, right? So in the meantime, in fact, I think my schedule is going to be a little, is going to get revised a little bit. I think the YouTube channel I think is going to change in terms of the kind of videos that we're going to put up. So do follow my do follow my Telegram channel. Let me put that here. That's Anand for Quant, right? No gap in there. Anand for Quant is my Telegram channel. So do find the channel link from there. Follow me, and you will get updates about my schedule in the following week. I hope to have a definitive answer for you either late tomorrow night or early Tuesday morning. Yeah. So keep following me, and I'll see you guys very, very soon. Before I split for the day, you guys are already here. Let me quickly tell you why Unacademy, the app, is great. Well, 3 big advantages. One, flexibility, right? It's an incredibly flexible platform, right? Not only, you can notice that here on YouTube, you ask a question, it takes some time getting to me. When I answer back, it takes some time getting to you, because there's a lag built in. On the app, there's no lag, right? Which means you can you can post a question in the chat and immediately the educator sees it, right? B, it's flexible also because it allows both communication to happen at both ends. If let's say you have a question that you've solved, you're not getting it, take a photo, upload it on the app, and the educator can see it live. He can pull it up on the screen also as the session is going on and solve it then and there for you, right? So doubt resolution is immediate, and more importantly, the educator can also ask questions and create polls that you can then answer. So interaction that happens at both ends. two-way interaction. Number two, it's also very, oops, I just talked about interaction, right? Right, so it's hugely interactive, right? Flexibility is what I talked about in the previous slide, so let me quickly sort of talk about that here. Well, flexibility, because unlike most things, this is an app that works on the web. Let's say you're studying and you have a laptop. You can run the app on your laptop. You can run it on your mobile phone. You can run it on your tablet. It can run on multiple devices. You can learn anytime, anywhere, right? Joining a subscription plan here means that there's no limit to how many classes you can attend. You can attend, classes by multiple educators on multiple batches in a language that you choose to, that you prefer, right? So incredible amount of flexibility, great interaction. And lastly, I think resources infinite. There's so much to practice because there's so many tests, there's so many mocks. You can analyze your performance using the reports available. You can download content in the form of PDF. Say for example, if this session had happened on the Unacademy app, the PPT would be there for you to download as a PDF, right? So you don't need to take notes, right? All you need is a valid subscription plan. Like I said, you get a 10% discount if you use my referral code. That's AV01 shown here at the bottom. And one more piece of advice I'll leave you with is, when you decide to subscribe, before you subscribe, obviously go download the app, try it out. There are special classes which you can attend for free. But once you've made up your mind and you're registering and you're subscribing to a plan, choose as long a plan as you can, right? If it's possible, choose a 1 year, 2 year plan, because really the value comes in a longer term, and not to sort of prepare for 2 months and then forget about it. If you're preparing, commit to it, go for a longer duration, and you will be able to extract greater value out of it. Trust me on that. Right? Well, that's my time today, guys. Thank you. Have a great day. Do like, share, and subscribe this video, and join and follow my Telegram channel. Yeah, I'll see you guys next week. Thank you. Have a great day and